Good evening, children.
Good evening, ma'am.
Good evening,
ma'am. Good evening, ma'am.
Good evening. All right, Ritika, Swati, and Bhavishya, kindly turn on your videos. Yes, Ritika and Bhavishya. Quickly turn on your videos. Yeah, good, Bhavishya. Ritika, turn on your video.
1 minute.
Yeah. All right, children, this is what we, this is where we stopped in the last class, I think. We understood the distributivity of multiplication over addition for rational numbers, and also distributivity of multiplication or subtraction for rational numbers. Distributivity or distributive property. Okay, so let us verify. We'll take up some statements and we'll verify this property. So let's try the second one in this, or maybe we'll do the first one. The second one can be a test. See the first one. So here, this one. 3 by 7 into 5 by 6 plus 12 by 13. So you can see multiplication, addition here. So distributive property of multiplication over addition is equal to 3 by 7 into 5 by 6 plus 3 by 7 into 12 by 13. I'll show you again. See here, 3 by 7 of, or you can say into 3 by 7 into 5 by 6 plus 12 by 13 is equal to 3 by 7 into 5 by 6 plus 3 by 7 into 12 by 13. So in this statement, we'll have to show that the LHS is equal to the RHS. If you do that, you verified the distributive property of multiplication over addition. So let's take the LHS. Let's take the LHS, children. So see here, first one we'll do together. The second one is a test. Please see this one. Tell me what should I do next?
Ma'am, you need to solve the bracket first, ma'am.
Bracket should be simplified first. Okay. So 3 by 7 into, what's the LCM of 6 and 13? Please find the LCM of 6 and 13. Addition. So you need to find the LCM of the denominators.
78.
78, correct. So 6 into 13, 5 into 13. So 5 13s are 65 plus 13 6 are, so 12 into 6. So 12 6 are 72 is equal to 3 by 7 into, what do you get on adding? 137. 137 by 78. Okay, so now this is nothing but a product of two rational numbers here. 3 by 7 is a rational number. 137 by 78. We simplified the brackets. We added in the bracket. We had to see 1 minute. Please watch this. In the bracket. In the bracket here, 5 by 6 plus 12 by 13. 5 by 6 is a rational number. 12 by 13 is a rational number. In the bracket, we have to find the sum of the two rational numbers, which we found using the LCM. And we got 137 by 78. Now we have two rational numbers, 3 by 7 and 137 by 78. Now we have two rational numbers, 3 by 7 and 137 by 78. connected by the mathematical operation multiplication. We need to multiply these two rational numbers. And how do we multiply? We multiply the numerators. How do we multiply? We multiply the numerators. We multiply the denominators. This is how we multiply. And after this, if simplification is possible, if you can cancel a number from the numerator and denominator using the same tables, you should do that. So 3 1s are 3 2s are 3 6 are 18. Yeah. 26. Now I don't think it's further possible to simplify. So we get 137 by, that is, you try to divide 26. 26 and 137. You try to simplify, see if it's possible. Otherwise, 1 into 137 is 137. 7 into 26. So 6 7s are 42. 4 carry over. Sorry, 182.
182, ma'am.
Correct, 182. All right. So we have simplified the LHS. Now let's take the RHS. Let's take the RHS. In the RHS, we have 3 by 7 into 5 by 6 plus 3 by 7 into 12 by 30. This is what we have. So now we have to simplify the bracket first. And in the bracket, we have multiplication. 3 by 7 multiplied by 5 by 6. So how do we multiply? We multiply the numerators. We multiply the denominators like this. Plus, again in the next bracket, we multiply the numerators. We multiply the denominators. And here, simplification is possible. 3 1s are 3 2s are. So we have 5 by 14. 5 by 14 plus, here you cannot cancel. You cannot cancel. So multiply. We get 12 3s are 36 by 13 7s are. What is 13 7s are? 91. Now find the LCM of, now what's addition? Now we have two rational numbers. We have simplified the two brackets. We simplified the two brackets and we got two rational numbers, 5 by 14 and 36 by 91. Now they have to be added up.
And 1274.
Oh, it's not so large. Oh, did you multiply 14 and 91?
Yes, ma'am. I used the L method, ma'am. In that 2 into 7 into 91, ma'am.
Swati, what is the LCM?
Ma'am, I got 1274.
1274. Huh?
Yes, ma'am.
Okay, let us check. Okay, let's check. Fine. Let's find the LCM of. I'll work it here, children. Don't get confused. I'm doing it here. I'm finding the LCM of 14 and 91. Okay. Now you may be right, Swati. I'm just thinking, like, is it such a big number? That's all. Okay. So now, what is it? 2 7s are and 91 as it is. 7 1s are 7 and 7 1s are 7. 2's the remainder, 7 3s are 21 and 13 1 1. Is this correct? Any doubt here, children?
No, ma'am.
Now the product 13 into 7 into 2 or 13 into 14 is the LCM. 13 into 14, meaning whatever number, whatever you see here. 14 into 13. What is 14 into 13? Yes, children, what is 14 into 13? What is 14 into 13?
Ma'am, I got 182.
192.
182, ma'am. 182, ma'am. Ma'am, I said 182, ma'am.
Oh, 182.
And for me to 182, ma'am.
Okay, 182. So 182 is the LCM. Now 14, how many times? 14, how many times 182? So divide and check. 182, 14. See, otherwise you can use this LCM, you know. How please listen to this, Nandana. Yeah, all of you look at your screen. All of you look at your screen. Yeah, now 114, how many times 182? See this LCM process. How will you get 14? 2 into 7 is 14, right? So take away these two numbers. See, like 2 into 7 into 13 we have. Now we have 14 here. We have 14 here. Take away 14, 2 7 are 14. So into 13 it is. 14 into 13 is 182. Did I explain something? Do you understand something? See, we have in the LCM, we have 2 into 7 into 13. Okay, we have 2 into 7 into 13. What I'm saying is the denominator here is 14. Strike out 14, 2 7s are 14. What is remaining? Into 13. That's what you should multiply the numerator and denominator by. And here we have 91. The other denominator is 91. Just write this. Write all these numbers. 2 into 7 into 13. Write 2 into 7 into 13. All the numbers you see here. 2, 7, 13. Now strike out 91. 13 7s are 91. So strike it out. 13 7s are 91. Strike it out. What is remaining? 2. So I should multiply the numerator and denominator by 2. I hope I explained it clearly. Now 13 5s are 65 plus 72. Which is equal to, and you should get the same answer, 137 by 182. So LHS is equal to RHS, and we have verified the distributive property. Hence verified. Hence verified. Please write down, children. We have verified the distributive property of multiplication over addition. I'll just come back. Please write. Ritika, you missed 2 classes. You requested the recording for 1 class, but for the other class you did not. So I just sent it.
Okay, ma'am.
But did you have time to go through the recordings?
Ma'am, I saw some, but I didn't see it throughout. Actually, I was in my, I was having a
You were having your?
cold, ma'am. I had a little fever cough.
Oh, okay. Okay, fine, fine. You're feeling better now?
Yes, ma'am, I'm better now, but I had throat pain throughout.
Oh, okay. Fine, fine. Take care. When you have time, you can just see the recordings, okay?
Yes, ma'am. Yes, ma'am.
Yeah, children, please get your questions answered. Ask your questions. So we are ready for the test.
Yes, ma'am.
Hmm. Okay, so I'm going to clear the slide. Finished writing, all of you?
1 minute, ma'am.
Okay. Yeah, done, children?
Yes, ma'am.
Okay. I'll clear the slide and also I'll unshare my screen. So as you are working, even I will work and we can check our answers later. Take down the second question. That's your test. If you finish the first answer, write down the second question. I'll unshare my screen. You cannot see my screen for some time. So as you're working, even I will work and we'll check our answers. Done?
Yes, ma'am. Copied.
Yeah. If you've not written, take a screenshot of the question, children. I'm unsharing my screen.
Ma'am, we should write only the second question, ma'am.
Only second. Yeah, yeah, right. Take only the second question now and try it. Yeah, yeah.
Yes.
Okay. I'm done, children. So since there are 4 of you, I'll divide the LHS into 2 and RHS into 2. So each of you will get to answer.
I get the answer. I'm 1 second, ma'am. I'm in the last.
No, please complete. Yes, we're not discussing now. I'll give you some time. Okay, please wait, child. Please wait. You're finished. Please wait. I'll give you 2 more minutes, 2 to 3 minutes to complete.
Yes, ma'am. I got my answer.
All right. Are we ready, children? I'll start with some just like that. Okay, we'll start with Nandana. Nandana, read out the LHS.
And LHS I got minus.
No. Oh, darling, read out your steps. LHS,
okay.
read out.
Okay, ma'am. Ma'am, first LHS is 15 by 4 into 3 by 7 plus minus 12 by 5, ma'am. The denominator, we should find the LCM, ma'am. The LCM is 35.
Okay. What do you have in the numerator?
Numerator, I got 15 plus minus 84, ma'am.
Very good. So next step, what will happen to 15 plus minus 84?
We should cancel it, ma'am. 15 and 34, ma'am.
You cancel 15 and 35, yeah?
Yes, ma'am. They come in 5 table.
No, but when it is addition, subtraction, you cannot cancel. You must subtract, no? 15 minus 84. Plus into minus, minus 15 minus 84. You didn't subtract.
I got it minus 69 by 35, ma'am.
Very good. Stop there. Okay, you're right so far. Yeah, Swati, continue. Did you get that?
Yes, ma'am.
Minus 69 by 35?
Yes, ma'am, I got that, ma'am. And next only we should multiply, ma'am. I left that point.
Nandana, no, you will stop there. Swati will continue. Yes, Swati, continue from the LCM.
Yes, ma'am. Ma'am, after that, we will be getting minus 69 by 35, ma'am. So we need to multiply minus 15 by 4 into minus 69 by 35, ma'am. Yeah. Since minus 15 and 35 will come in the same table, ma'am, in 5 tables, so we cancel out, ma'am. So we will be getting minus 3 and 7, ma'am. And 4 and minus 69 will not be crossed out, ma'am, since they will not come in the same table. So we multiply minus 3 into minus 69, ma'am. So we will be getting minus into minus plus, ma'am. So we'll be getting 207 and 4 into 7 and it's 28, ma'am. So 207 by 28 is the LHS answer.
Very good. 207 by 28. That's what even I got. 207 by 28 is the value of the LHS of the statement. Very good. Yes. Good girls. Nandana and Swati. Good. Okay. Now, since Bhavishya, not Bhavishya, Mithika, since you missed The last class I'll ask Bhavishya and then you may continue. Bhavishya, RHS.
Ma'am, I haven't finished RHS, ma'am.
You haven't finished RHS? What about Mritika?
Yes, ma'am. I too didn't finish, ma'am.
And can I tell RHS?
Okay, now I'll share my screen so that you can see the answer. Maybe next one you can catch up with the others and complete it on time. I'll just share my screen now. Please see the answer. Yeah. No problem, Bhavishya and Mritika. It happens. All right. Bhavishya and Mritika, any questions?
No, ma'am.
No, ma'am.
Okay. Can I clear the slide? Have you finished writing this?
Yes, ma'am. Check the answer, ma'am.
Okay. So in the RHS, in the bracket, in the first bracket, we have a product of two rationals. In the second bracket also, we have a product of two. We have to multiply. We don't have a product. We have to multiply two rationals. We'll have to find the product of two rationals. In the two brackets, we have two rational numbers which have to be multiplied, whose products have to be found. So how do we find the product of two rational numbers? We multiply the numerators, we multiply the denominators like this. Do the same thing in the next bracket. And then if simplification is possible, simplify. And that gives you -4. Then when you multiply, -15 into 3 is -4. -15 into 3 is -45. 4, 7, the 28. And here we have -3 into -3, which is +9, which is nothing but 9 by 1. Now the LCM of 1 and 28 is 28. So we need to multiply this by 1 and this one by 28. This one by 28. And then, yeah, -45 plus 252, which is 207. -45 plus 252 is plus 207. Different signs, subtract and put the sign of the greater number. All right. Now, 3 you can try as homework. We'll do the 4th one. Or if you've written the 3rd question, children, we'll do the 3rd one now and 4th will be homework. Has anyone copied the question already, the 3rd question? Has anyone copied the 3rd question already and started working?
No, ma'am, I copied first and second, ma'am.
Okay, fine. So 3 is homework. 3 homework. 3 homework. We'll do the 4th now in the class. We'll do the 4th one now. So 3 is also distributive property. Just that this one is here. Into 5 by 6 is in the end. Like we have 3 by 7 here in the beginning. Here that's in the end here. That's all. It's the same thing. Minus 8 by 3 into 5 by 6 plus minus 8 by 3 into 5 by 6. Sorry, minus 13 by 2 into 5 by 6. Sorry, minus 13 by 12 into 5 by 6. Let me tell you clearly again. Minus 8 by 3 into 5 by 6 in the first bracket. Minus 8 by 3 into 5 by 6. Then this plus minus 13 by 12 into 5 by 6. Minus 13 by 12 into 5 by 6. Homework. Do the 4th one. Alright, I'm sharing my screen. I'll also work with you. Yes, children. What's the value you're getting in the LHS? Anyone complete the LHS?
592 by 126.
126.
26.
Okay, you're right, but you did not simplify. That's all. Should
Yes,
simplify
ma'am.
further. Yeah. Anyone else? What's the value of the LHS?
Ma'am, I got 296 by 63, ma'am.
Yeah, even I got the same thing. That's good. Yeah, 296 by 63. Okay. Nandana, you're not wrong. You have to simplify. You have to write the rational number in the simplest form.
And is it 296 by 63?
Yeah, you're right.
Ma'am, got the value for RHS also, ma'am.
Yeah, the same thing.
Yes, ma'am, same.
Yeah.
And that is 128 plus 168, ma'am, by 63.
128 plus
168 by 63, ma'am.
correct, correct. Yes. Bhavishya, can you start with the LHS?
Yes, ma'am. Minus 16 by 7 into minus 8 into 6 by 9 into 6 plus minus 7 into 9 by 6 into 9. It is minus 16 by 7 into minus 48 plus minus 63 by 54. Minus,
What's your LCM? What's the LCM of 9 and 6?
54, ma'am.
Oh, you should not multiply 9, 6 or 54 is a common denominator, but that's not the least common denominator. Work the LCM of 9 and 6 and tell me. Okay. Work the LCM of 9 and 6. Least common multiple. 54, yes, is a common multiple of 9 and 6, but that's not the least common multiple.
Ma'am, 16.
16 for 9 and 6. What's the least? How much?
Ma'am, I have done in 3 table, ma'am. For 9, 3 and 3s are 9, and for 6, 2 3s are 6, ma'am.
So you'll get 3 and 2. Yeah.
Yes, ma'am.
So what's the LCM?
Ma'am, I'm getting 3 into 3 into 2. Ma'am, for the 3 into 3, 9 and 16, ma'am.
9 2s are 16, huh?
Yes, 18, ma'am.
That's what. You're not showing your face. Adjust the lid of your laptop. Yeah. 9 2s are 18 is the LCM. Okay, who's taken 18 as LCM? Read out your steps. You must not take denominator 54 because unnecessarily you will get big numbers. You must take the LCM.
Ma'am, I also got the same answer, ma'am. 296 by 63.
Have you taken the LCM as 18? Nandana and Swati, Mritika?
Yes, ma'am. I took the LCM as 18, ma'am.
Okay, then what do you have in the bracket? Minus 16 by 7 into? Upon taking the LCM, you get?
Ma'am, minus 16 by 18 plus minus 21 by 18, ma'am.
Okay, then next step?
Ma'am, we need to add minus 16 plus minus 21, ma'am, since same signs. So minus 37 by 18 into minus 16 by 7, ma'am.
Correct.
And we simplify further, ma'am, minus 16 and 18. So minus 8 and 9, ma'am. Minus 8 into minus 37, 296, ma'am. And 7 into 9, 63, ma'am.
Very good, very good. Yes. Very good. And what should we do in the RHS, children?
Ma'am, for LHS, I took LCM 18, ma'am. But for RHS, I took it 126, ma'am. But the answer is same, ma'am.
Now, what did you take? For the RHS, you took what?
126.
120. Oh. You didn't simplify then. No, you should do this. Otherwise, the numbers will be large.
Yes, ma'am, I simplified it.
Yeah, you will get the same answer. You will get the same because finally you will simplify. So that means you have 128 by 63 plus 16 by 6, is it?
Yes, ma'am.
That's why. So you got LCM as 126.
Ma'am, I got LCM as 63 only, ma'am.
63 because when you simplify it, when you simplify till the end, then it is 8 by 3. 128 by 63 plus 8 by 3, correct? 128 by 63 plus 8 by 3, yes or no?
Ma'am, I didn't do like that, ma'am.
Now, what's the fraction then you got?
Oh, yes, ma'am. 128 plus 168 by 63, ma'am.
No. When you multiply, when you find the product, what is the product of one bracket? 128 by 63.
Yes, ma'am.
What is the product of the other bracket?
Ma'am, 168 by 63, ma'am.
Oh, you multiplied.
Sorry, ma'am. I got my 8 by 3 as the answer, ma'am.
8 by 3, yes. 1 minute, I'll share my screen now.
Ma'am, after adding, I told you, ma'am.
Okay. Yes, children. For addition, subtraction, you need to take the LCM. When it's multiplication, no LCM. Multiply the numerators, multiply the denominators.
Ma'am, I simplified for minus 7 and 7, ma'am. I didn't simplify for 6 and 16, minus 16.
That's fine.
So that only I got that.
Correct. Now you will get marks. It's not that you will not get marks, but you must simplify to the maximum extent.
Yes, ma'am. Check the answer.
Yeah. So we have checked the distributive property of multiplication over addition. Now sometimes the question will be given like this. It will be like this. If, let me tell you the question for the first one. If A, or for the second one, if A is equal to minus 15 by 4, B is equal to 3 by 7, C is equal to minus 12 by 5. Verify the distributive property of multiplication over addition. They'll not give you how the statement will look like. They'll just give you the values of A, B, and C, because for the distributive properties, for the distributive property, we take three rational numbers. So you will be given three rational numbers like A, B, C, or X, Y, Z, P, Q, R, whatever. And you will be asked to verify the distributive property of multiplication over addition. Then you need to write like this. So this is what you should verify. See if this is A into B plus C is equal to A into B plus A into C. I'll write it more clearly. I need to clear the slide. Please write this answer. I'll show you again. Complete this answer. I'll show you.
Already completed, ma'am.
Okay. Others?
Completed.
Anyone still writing? Okay. Okay. So I was telling you that I'll just take the second one as the example. For the second one, the question can be if A is equal to minus 15 by 4. Look at the second statement there. B is equal to 3 by 7. C is equal to minus 12 by 5. Verify the distributive property of multiplication over addition. This will be the question. So then you should frame the statement. What is the distributive property? What is it? How does it go? The distributive property. I'm just writing in short, okay? So distributive property of multiplication over addition. Don't write like this, children. So distributive property of multiplication, this is over addition. How will it be? Is equal to A into B plus C is equal to A into B plus A into C. Must write this rule. A into B plus C is equal to A into B plus A into C. So what should you verify? You should verify minus 15 by 4 into 3. Use the values of A, B, and C. Minus 15 by 4 into 3 by 7 plus minus 12 by 5 is equal to A into B. Minus 15 by 4 into B, 3 by 7, plus, write it below, plus A into C, minus 15 by 4 into minus 12 by 5. So here we are given the statement directly. One second, children, just a second. Yeah, thank you, children. So here we are given, the statement, and the idea is verify the following, and you're given the statement. So you will simply work the LHS, You'll work the RHS and you'll say hence verified. You'll get the same answer in both, so hence verified. You will not even be mentioning it as the distributive property of multiplication over addition. So the question can be like this also. Given A, B, C or given X, Y, Z, verify the distributive property of multiplication over addition. So if it's X, Y, Z, you must write X into Y plus Z is equal to X into Y plus X into Z. Just replace A, B, C with X, Y, Z. A with X, B with Y, C with Z. If it's P, Q, R, replace A with P, B with Q, C with R. Is that fine, children?
Yes, ma'am, understood.
All right. Oh, I didn't know that I'd worked it already. I thought I did not work. I didn't check it on. This is. That is homework, no? Okay. I have the answer for the next one also. Yes. Yeah, Mritika. First one, answer the first one, Mritika. Name the property of multiplication illustrated by each of the following statements. How many rational numbers do you see in the LHS or in the RHS?
2, ma'am.
Or in the statement, in all, how many rational numbers are there? Like
4, ma'am.
not 4, but yeah, 4, but we have the same thing. No, the same thing is repeated. So we have 2. If it is 2, what property can it be? Closure, associative, commutative, distributive.
I think it's commutative property.
Commutative property of what's a mathematical operation?
Multiplication.
Multiplication. Commutative property of multiplication of what kind of numbers are they? Minus 15 by 8, minus 12 by 7. Are they natural numbers?
Rational numbers, ma'am.
Rational numbers. They are rational numbers. So the statement, the first statement illustrates the commutative property of multiplication of rational numbers. Commutative because we have only two different rational numbers then. In all we have 4, but we have only 2 different rational numbers. Minus 5, oh my God, minus 15 by 8 and minus 12 by 7. These are the 2 rational numbers we see in the LHS and RHS. And they just multiplied in different order. In the LHS, it's like A into B. In the RHS, it is B into A. So whenever it is A into B, B into A, it is commutative. When we have AB, BA, it is commutative. If it's connected by the plus sign, it is of addition. Here it is multiplication sign, so of multiplication. Commutative property of multiplication of rational numbers. Second one, Nandana, second one.
And second one is associative property of multiplication of rational numbers, ma'am.
Very good, very good. Associative property of multiplication of rational numbers. How many different rational numbers do you see in the statement?
And 3.
We see 3 different rational numbers in the statement. In the LHS, we have 3. In the RHS, we have the same 3. The same 3 we have in the RHS also. But it's just that we are multiplying by grouping in different orders. Here we group the first 2. Here we group the last 2. See the same rational numbers. Minus 2 by 3. See, this is the equal to sign. This is the equal to sign. Minus 2 by 3. Minus. Okay, 1 minute. The first rational number is minus 2 by 3. Here also the first one is minus 2 by 3. The second one is 7 by 9. Here also the second one is 7 by 9. The third one is minus 9 by 5. Here also the third one is minus 9 by 5. Then what's the difference? Here in the LHS, we are multiplying the first two rational numbers. And then that is, we are finding the product of the first two and that result with the third one. In the RHS, we are finding the product of the last two. We have grouped the last two. So we'll find this one first and this result will multiply with minus 2 by 3. So we're just grouping, we've just grouped in different order. Very good. So associative means we'll have three numbers A, B, C. Associative property of multiplication of rational numbers. Very good. Swati, third one. Bhavisha, be ready with the fourth one. Swati, third one.
Yes, ma'am. Ma'am, the third one is A into B plus C, ma'am. And in the RHS, the working model is A into B plus A into C, ma'am. So the third statement illustrates the distributive property of multiplication over addition, ma'am.
Very good. Very good. Yes. Tell me the property using the rational numbers A by B, C by D, and E by F.
Ma'am, it's the distributive property of multiplication over addition of rationals.
No, you said A into B plus. Okay,
yes, ma'am.
Use the rational numbers.
Yes, ma'am. Yes, ma'am. Ma'am, shall I say?
Yeah, tell me C by D and E by F. And illustrate the distributive property of multiplication over addition.
Yes, ma'am. Ma'am, A by B into C by D plus E by F, ma'am. In the RHS, it will be written as A by B into C by D plus A by B into E by F, ma'am.
Yeah, correct.
Ma'am, you have written plus, ma'am.
Sorry, yeah. Yeah. Oh my God, here also. Yeah, correct. A by B into A by B into C by D plus E by F is equal to A by B into C by D plus this plus A by B into E by F. Okay, so Swati was right with the third one. Yes, Bhavisha, fourth one.
Fourth one is closure property on multiplication.
No, you should say the most appropriate property. Sometimes, another property might look correct, but the most appropriate property.
It is commutative property.
Yeah, okay. If it is commutative property, you will not get this one. This one will not be mentioned. This will not be there. Sorry.
Shall I try?
This will not be there, Bhavishya. They'll only write minus 16 by 9 into 1 is equal to 1 into minus 16 by 9. Then you're right. Then it is like commutative also. Commutative property of multiplication over. But when there is one, you should not say commutative. That's why I said you should say the most appropriate one. Mritika?
Ma'am?
Yeah. I don't know if you missed this class. Is it familiar to you?
Yes, ma'am.
Yeah, tell me.
Fifth one or which one?
Fourth one.
Okay. I don't know, ma'am, about this.
No problem. No, because you missed 2 sessions and maybe you have missed the introduction to all this there. So please watch the recordings.
Ma'am, shall I?
Okay.
Yes, Swati?
Ma'am, it's multiplicative identity, ma'am.
Correct. Multiplicative identity of rational numbers. Because when you multiply a rational number by 1, or if You multiply, or if 1 is multiplied by any rational number, the answer is the rational number itself, identical, same answer. When we multiply, see here, when we multiply a rational number by 1, or if you multiply 1 by any rational number multiplied by 1, or 1 multiplied by a rational number, the answer is the rational number itself, So this illustrates the multiplicative, illustrates that 1 is the multiplicative identity of rational numbers. Identity, because you're getting identical answer, same answer you're getting, minus 16 by 9. Rational number itself you're getting as the answer. When do you get that? When you multiply the rational number by 1, you will get the same answer. So the fourth one represents or illustrates or demonstrates the multiplicative, not inverse, identity, multiplicative identity of rational numbers. That is, rational number multiplied by 1 is equal to 1 multiplied by the rational number is equal to the rational number itself. See, what is the answer for this one? The answer for this is this, minus 16 by 9. What is the answer for this? What is the answer for this one? That also the answer is minus 16 by 9. So for both the answer is minus 16 by 9. So it's written continuously like that. A into 1 is equal to 1 into A is equal to A. A into 1, or you can say A by B into 1 is equal to 1 into A by B is equal to A by B. Okay. Yes, next one, Bhavishya, you can try this again.
It is additive inverse of multiplication.
Where is the addition symbol here?
No, multiplication.
Multiplicative identity or inverse? We have only two things, identity or inverse.
Yes, ma'am.
Identity, yeah?
Yes, ma'am.
No. Fourth one is identity. Fifth one is inverse.
Multiplicative inverse, ma'am.
Multiplicative inverse. Yes, multiplicative inverse of rational numbers. See here, this is the rational number. When you multiply it by its inverse, how do you find the inverse? Just turn the rational number, write it upside down. Don't change the sign, write the same sign. With the same sign, turn the rational number upside down. The rational number is minus 11 by 15. Turn it 15 by minus 11. Now, if the rational number is 15 by minus 11, turn this minus 11 by 15. In both these cases, in this case and in this case, the answer is 1. Because 11 gets cancelled, 15 get cancelled, and minus 1 into minus 1. In the numerator, you have minus 1, in the denominator, you have minus 1. 1 and 1 cancels, the answer is 1. Here also 15 and 15 will get cancelled. Or you can say minus 11 and minus 7, they get cancelled. So the answer is 1. Here also you can say minus 11 gets cancelled. The answer is 1.
Ma'am, it's also known as the reciprocal of rational numbers, ma'am.
Reciprocal, yes. Reciprocal of rational numbers. So in 5, what is demonstrated? Multiplicative inverse of rational numbers. Inverse. That is 15 by minus 11 is the multiplicative inverse of minus 11 by 15. Or minus 11 by 15 is the multiplicative inverse of 15 by minus 11. See, from this what you can say is 15 by minus 11 is the multiplicative inverse of minus 11 by 15. From this, what can you say? Minus 11 by 15 is the multiplicative inverse of 15 by minus 11. The product of a rational number and its multiplicative inverse is 1. The product of a rational number and its multiplicative inverse is 1. See, when you take this one, the product of a rational number and its multiplicative inverse. This is the rational number. This is the multiplicative inverse. The product of a rational number and its multiplicative inverse. What's the answer? The answer is 1.
Always 1.
It's 1. We've written that as a continued statement. If you treat this one as a rational number and this one as its inverse, the product of the rational number and its inverse is this one. The product is 1. So what is demonstrated or illustrated here? Rational number inverse. Rational number inverse. The product of a rational number and its inverse is 1. So it represents the multiplicative inverse of rational numbers.
Ma'am, and also multiplicative inverse of 0 does not exist, ma'am.
Yeah, inverse for 0, because 0 means 0 by 1 and its reciprocal is 1 by 0, which is not defined. So 0 has no reciprocal. The number 0 has no reciprocal because we can just do it ourselves. 0 means 0 by 1 or 0 by 2. We'll treat it as 0 by 1. 0 is 0 by 1. And the reciprocal of 0 by 1 is 1 by 0. But 1 by 0, denominator is 0. Such a value does not exist or is not defined. So 0 has no reciprocal. The reciprocal of 0 is not defined. What about the last one? The last one, you can just say a property of 0. That's all. When a rational number is multiplied by 0, the product is 0. It's the property of 0 on multiplication of rational numbers.
Ma'am, anything.
0. Yes.
Ma'am, anything multiplied by 0 gives 0.
0. Any number multiplied by 0 is 0. That property is what is reflected there.
Yes, ma'am.
All right. See, children, don't get confused. If this is not given, then you may think it is the commutative property because this is like A and this is B and this is A. A into B is equal to B into A. So commutative property. No, but it's given is equal to 1. That means they're trying to say that the product of a rational number and its inverse is 1. So that is multiplicative inverse of rational numbers, not the commutative property. That's what I said. You should give the most appropriate property. Because we have this is equal to 1, it is not commutative property, which is expressed there. It is the multiplicative inverse of rational numbers. Swati, your school Kamla Niketan uses which book? Exceed, huh?
Ma'am, this year they gave both, ma'am, NCERT for reference and Exceed for the class use, ma'am. Okay, so
yeah, no, they always do that. They give NCERT for, so they're using NCERT and because once they switched to EDAC, so again they've gone back to Exceed, is it?
Yes, ma'am.
You had EDAC, no, sometime back? No?
No, ma'am.
Okay, no problem. Fine. Okay. Maybe when my daughter was studying, she had EDAC once.
Yes, ma'am.
What about in Z school, Ritika? Textbook followed?
NCRT, ma'am.
Only NCRT.
Only NCRT.
Only NCRT. Bhagisha Vidyashram, only NCRT. Bhavishya?
Yes, ma'am.
Okay. So children, now you will wonder that, this lady is doing something which is not an NCERT. These properties, these questions you will not find in NCERT. How we will be going about every chapter. Every chapter will comprise. So this is my material. Every chapter will comprise of questions from Agarwal, R.D. Sharma, or some question banks. I would have pulled out questions from different sources and put everything in one, and that makes one chapter complete. So when we finish a chapter here, you're exposed to questions from books by different authors. So you're actually exam ready. No question in your exam will look unfamiliar for you. There may be rarely, but you will be able to handle it. You might find a different question, because there are varieties. You might find a different one, but you will have the knowledge to handle it, provided you practice regularly. Okay, so these are not found in NCERT, but very important, forms a very important part of the chapter, rational numbers. So what you should do is you should maintain your, this classwork notebook, tuition classwork notebook neatly. Maintain this book neatly. Maintain your school classwork notebook, maths classwork neatly. So now supposing they finished rational numbers in school, and we also finished rational numbers here, and your school has announced a test on rational numbers. So how to prepare? You must go through rational numbers from your school classwork notebook. You must go through rational numbers from the tuition classwork notebook. I think that with that you will be ready for the test or exam. Beyond that, if you have time, you can probably, if you have, I suggest don't get any reference book. Because if you simply work many things once, you work sums from different books once, you may forget. You can retain only when you practice the same thing which you've understood again. You've understood something in your school and in the tuition class here. You must practice the same sums. That's how you prepare. Your teacher in school teaches you something. Practice that. Here we learn something. Practice this. Practice what you have learned, what the teachers have taught you. That's more than sufficient. Only that way you grow, you become more confident with the subject. If for the exam, supposing, for a test on rational numbers, you don't open your school notebook, you don't open your tuition notebook, from somewhere somebody told you download something from the internet, that content is very difficult, it's, all that will come for the exam, and you start learning something new. So you would have forgotten school, whatever the school teacher taught you, because you didn't practice. What we learned here also you would have forgotten because you didn't practice. And again, something new from the internet you're learning, which you will just do once. So in the exam, everything will be like, you'll only see stars in the exam. Because you did not practice the same thing. You did not repeat whatever you understood, whatever you had understood. You've been learning new things. So only once you have seen everything, and everything will forget after some time. So how to revise, how to practice is practice the same thing. Whatever you've been taught or whatever you've understood, you must repeat that. Practice the same thing again. That way you can retain the concepts well. Okay, so now here are the answers, children. Please write down. Now in the class, please write down. You don't take it down like this. Write the question, write the answer from below. Don't write all the questions and then all the answers. Take one question, write its answer. Done, children? Finished writing, children?
No, no, ma'am.
Okay, okay.
Complete.
Yeah.
Done with all the 6, ma'am.
All right. Yes. We'll just answer the, we'll just answer the whatever should come in the blank. You may write it later. The product of a rational number and its reciprocal is?
Always 1, ma'am.
Yeah, the product of a rational number and its reciprocal is always 1. 0 has? Anybody
No
can answer.
reciprocal.
No reciprocal, ma'am.
0 has no reciprocal, correct?
Yes, ma'am.
Okay. The numbers dash and dash are their own reciprocals.
Minus
1 and minus 1.
Ma'am, -1 and +1.
Yeah, correct. Very good.
minus 1.
Numbers +1 and -1, or you can simply say 1 and -1. Because what is the reciprocal of 1? 1 itself. What is the reciprocal of -1? -1 itself. Yeah. The reciprocal of 1 is 1. The reciprocal of -1 is also -1. Because 1 into 1 is 1. -1 into -1 is 1. We know that reciprocal means the product of a number and its reciprocal should always be 1. Only then it's the reciprocal. The product should be 1. The product of the number and its reciprocal should be 1. So 1 into 1 is 1. -1 into -1 is 1. If the product is 1, that means 1 is the reciprocal of 1. 1 is the reciprocal of 1. -1 is the reciprocal of -1. So 1 and -1 are their own reciprocals. 0 is the dash. 0 is dash the reciprocal of any number. 0 is dash the reciprocal of any number. Zero is not the reciprocal of any number. 0 is not the reciprocal of any number. Correct?
Yes, ma'am. Ma'am, I thought something complicated.
Yeah, that's what happened. Correct. 0 is not the reciprocal of any number. Yeah. The reciprocal of A, where A is not 0. A is not 0. Okay. So the reciprocal of A is
A 1 by A, ma'am.
1 by A, because A means A by 1. The reciprocal of A, that is A by 1, is 1 by A. The reciprocal of A. See, this is just another information given to you. A is not 0. A is not, this is just an information. A is not 0, that's all. So the reciprocal of A, what is A? A means A by 1. The reciprocal is 1 by A. The reciprocal of 1 by A, again where A is not 0, because they're telling you that this is not 0. This one is not 0. The reciprocal of 1 by A is?
A by 1 or A, ma'am.
A by 1 or A. The reciprocal, let me clear the slide. The reciprocal of a positive rational number is, take a positive rational number, children.
It's a positive rational number.
Take a positive rational number. Okay, so 2 by 5 is a positive rational number. What is its reciprocal? Is it
5 by 2, ma'am?
5 by 2. It's not minus 5 by 2. It is just 5 by 2. Because the product of 2 by 5 and 5 by 2 is 1. Now, supposing you take a negative rational number minus 2 by 5. What is its reciprocal?
Minus 5 by 2, ma'am.
Yeah, you write minus 5 by 2 or 5 by minus 2. Both are the same. 5 by minus, just turn it. 5 by minus 2. Minus 2 cancels, 5 cancels, the product is 1. So you can see that when the rational number is positive, its reciprocal is also positive. When the rational number is negative, its reciprocal is also negative. The reciprocal of a positive rational number is positive. The reciprocal of a negative rational number is negative. Okay, now tell me, is this a positive rational number or negative rational number?
Ma'am, positive rational number, ma'am. When we cancel the minus, we get a positive number.
Yeah, so minus 3 by minus 4 is not negative. It's only 3 by 4, so it's positive. Minus 3 by minus 4 is positive. What about minus 5 by 6? Is it positive? Is it a positive rational number or negative rational number?
Negative rational number, ma'am.
What about 5 by minus 6?
Negative, ma'am.
Negative rational number. What about 1 by 2? Positive or negative?
Positive, ma'am.
Now?
Positive, ma'am.
Positive. Yes. Take a screenshot. Please complete this.
Yes, ma'am, took screenshot.
All right. Just need to give you some. Done, children? All of you?
Yes, ma'am.
Taken this. Okay.
Yes, ma'am.
Please wait. So all of you might have learned representing rational numbers on a number line. Have we all learned?
Yes,
Just give me
ma'am.
5 more minutes. Just give me 5 more minutes. Representing rational numbers on a number line. Now, how do we represent 19 by 7 on a number line? 19 by 7. Let me, 1 minute. Yeah. How do we represent 19 by 7 on a number line?
Ma'am, between 2 and 3.
Yeah. Between 2 and 3. So you need to use your ruler. Don't do it now, children. Let's just listen. We'll just listen. You just listen to me. You can complete it later. Take a scale. Draw a line. You need to represent 19 by 7 and minus 19 by 7. Okay, so take 0. Take 0. Then using your scale, that half a centimeter mark. Half a centimeter mark. 1 centimeter. In the middle, you have between 0 and 1, you have half a centimeter, right? 0, this is 0 on your scale, this is 1. In between, you have no that 0.5. So mark off all those points. 0.5, 1, 1.52. I hope you understand 2.53. Mark off those points and then we'll write the rational numbers pertaining to these lines. So these divisions are at distances of 0.5 centimeters. Are at distances of 0.5 centimeters. So 0. I'll write 0 as 0 by 7. This one will be 1 by 7. This will be 2 by 7. This will be 3 by 7. 4 by 7. 5 by 7. The denominator is 19. In 19 by 7, the denominator is 7. In 19 by 7, the denominator is 7. So I write 0 as 0 by 7. You don't have to show this, but just think, you just read. When you see 0, read it as 0 by 7 in your mind. 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7. This is 1. This is 1. This after 0, this is 1. Now 8 by 7, 9 by 7, 10 by 7, 11 by 7, 12 by 7, 13 by 7, 14 by 7. This is 2. 14 by 7 is 2. So this is 1, this is 2. Go on. 15 by 7. You can write 19 by 7 as a mixed fraction and check where it lies. So 7 2s are 14. 7 2s are 14. 5 is a remainder by 7. So clearly it lies between 2 and 3. 19 by 7 will lie between 2 and 3 because it's 2 5 by 7. It's a little more than 2. It's between 2 and 3. Because when you write it as a mixed fraction, you get 2 5 by 7. So which is more than 2 but less than 3. So go on, children. 15 by 7, 16 by 7, 17 by 7, 18 by 7, and 19 by 7. So this is the position of 19 by 7. After that, you can just write two more. Now 20 by 7 and 21 by 7. 20 by 7 and 21 by 7. That 21 by 7 is 3. 21 by 7 is 3. Now your question will be what should be the distance between these two? The distance between any two consecutive marks must be the same. It can be anything. It should be the same. If you take half a centimeter gap here, everywhere it should be half a centimeter. The distance between any two consecutive marks. Any two consecutive markings. It should be, you should jump by half a centimeter everywhere. Half centimeter everywhere. So when you have to mark a lot of numbers, let the space be less. Then only you can show all the numbers on your page. So here I think half a centimeter, gap will help you. Now similarly on the other side, children. So what is it? 19 by 7. So look at 0 as 0 by 7. So next you will write 1 by 7, 2 by 7, 3 by 7, 4 by 7. 7 by 7 is 1. 14 by 7 is 2. 21 by 7 is 3. And here it is 19 by 7, 19 by 7. So you can just mark this point as A. Then you can write A represents 19 by 7. A represents 19 by 7 on the number line. On the number line. Similarly, on the other side, for minus 19 by 7, minus 1 by 7, minus 2 by 7, minus 3 by 7, minus 4 by 7, please go on like that. Minus 7 by 7 is minus 1. Then I'm writing it here, but it will not come so quickly. Minus 14 by 7 is minus 2. Minus 21 by 7 is minus 3. And somewhere here you will get minus 19 by 7. Minus 19 by 7. You can mark this point as B, or you can call it A dash. A dash represents minus 19 by 7 on the number line. On the number line. Similarly, if it is 13 by 5, you must say 0 by 5, 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. That's 1. 10 by 5 is 2. If you have to represent 13 by 5, 13 by 5. Then you should treat this one as 0 by 5. Then next is 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5 is 1. 10 by 5 will be 2. Is it understood, children? Understood? Bhavishya, Nandana, Ritika is not there. Swati, have you understood?
Yes, ma'am. Understood, ma'am.
Why Swati from 2 different devices? Okay. Understood, children? Nandana, Bhavishya, I can see only you both. Swati, understood?
So I rejoined again, ma'am.
Okay. Is it understood?
Yes, ma'am.
All right, children. All right, children. So that's it for today's session. Thank you so much. Complete your, oh yeah, your homework. Yes. This one, all these, what you see here, question number 1, 2, 3. And then do only these. This one. That's all. This, all these questions. Question number 1, 2, 3. Take a screenshot. Question number 1, 2, 3. And the 3 sums which I've circled. Only what I have circled. Okay, let me circle some negative numbers also. Here we have negative. Let me circle some negative numbers. -3, 1 by 7. So yeah, these. This form, work only the circle questions here. All right, children. That's it for today's session. Thank you. Good night.
Good night, ma'am.
Thank you, ma'am.
Good night, children. Thank you. Good night.